In this video, I will be explaining how to solve some introduction problems of indefinite integrals. So this will be integrals and you just need to use the rules of integration. The first problem that we have today, we are going to solve 3 of them, but the first problem we have today is this one. We have the integral of x squared minus 4x plus 1 dx. What to do? So we notice immediately that this is a polynomial, this is a sum. So for obtaining the integral of this function, what we are going to do is just getting the rule that say that if we have the addition of 2 functions, we add the integral. Or if we have the difference of 2 functions, like in this way, we get the integral of the first one minus the integral of the second one. So for solving this problem, what we're going to do is getting the integral of the first function that I see here, x squared dx, minus the integral of the second function, so minus the integral of 4x dx, plus the integral of this function, that is the constant function 1. So it will be plus the integral of 1 dx. So we have to use just the sum or difference rule. So if we have a sum of functions, we get the integral of the first function plus the integral of the second function. Or if we have a difference of functions, we get the integral of the first one minus the integral of the second one. And now here we observe that we have a constant 4 multiplied by a function x. So I can think that this integral is just 4 multiplied by the integral of x dx. So I can think in this that is a constant multiplied by a function. And anytime that we have something like this, we can get the constant multiplied by the integral of the function. So for solving this problem, I know that I need to get the integral of x squared dx, but this one will be, so the 4 can be written outside of the integral. So I can write minus 4 the integral of x dx. So it will be the constant multiplied by the integral of the function. Plus, and the same here, this one can be thinking that this is 1 multiplied by the integral of the x. So I noted that the 1, I don't need to type it. Also, I can think that this is 1 dx. This is just dx. So anyway, so this will be just the integral of the x. And here what I have used is just the constant times a function rule. So we have a constant times the function, so we can get the constant outside of the integral that multiply the whole integral. And now I notice that this is a power, the integral of x squared, and we have a rule for the power function. If we have x to any power, we can add 1 to the power, and this new exponent will be written also as a denominator. So if this is x to the power 2, I can type x to the power 3, add 1 to the exponent. And the new exponent will be also the denominator. You can type 1 over 3 multiplied by x to the power 3. Or you can type also x to the power 3 divided by 3. That is the same. But anytime that I compute the antiderivative, I need to get the constant of integration. So when I'm computing this first integral, appears a constant of integration. The same is going to happen in the second integral. For that reason, I'm calling this constant of integration c sub 1. So this will be the first constant, or the constant related to the first function. Okay, let's work with the second function. Again, we have here a 4, but this is x to the power 1. I add 1 to the exponent, we have x to the power 2. And this x to the power 2 will be divided by 2. So it will be 1/2 of x to the power 2. So I'm going to type here minus 4 multiplied by the integral of this, that was 1/2 of x to the power 2. And as any integral, when I computed an integral, appears a constant of integration. And the same is going to happen in the last one. You can continue be thinking that there is a 1 here. So if there is an x to the power 0, you can add 1 to this exponent 0, and you're going to get x to the power 1 divided by 1. So it will be x to the power 1, or just x. So for the integral of dx, it's just x. Anytime that you have dx, the integral will be just So the integral of the x will be x plus a constant of integration. And this constant of integration will be the one related to the third integral. For that reason I call it c sub 3. So what I have used here is just the power rule of integration. So we have it used here, and for computing this integral of x to the power 0. So this is the power rule for integration. So anytime that we have a power, we add 1 to the exponent, and this new exponent is going to be written as the denominator. You can type 1/3 of x to the power 3, or you can type x to the power 3 over 3. Here, x to the power 2 over 2, for example. Okay, now let's simplify this expression. First thing that I notice is that I have 3 constants. If I have 3 constants, and I add these 3 constants, the answer will be just 1 constant. So if, for example, this is number 7, and this is number 8, and this is number -2, when I add these 3, will be just 1 constant. So it's not necessary to type 3 constant. From now on, anytime that I have several integrals, I'm just going to type a constant at the end. And here, for example, I notice that 4 over 2 can be written 2. Yeah? So it will be 2 multiplied by x to the power 2. So I can simplify this, typing that this is 1 over 3 x to the power 3. This will be 4 over 2 is 2, so it will be -2 x to the power 2. Here will be this plus x, and now noticing that this 3 constant is just 1 constant, just gonna type a constant at the end. And this solves the first problem, just using rules of integration. I have used here the sum or difference rule, the constant times a function rule here, and here was the power rule. So the same is gonna be doing in a similar way, using maybe other rules in the following 2 examples. Here we have another example of integration. So we have a sum again of several functions. So we are going to use the sum or difference rule for getting this integral. But now I have the integral of e to the power x. This is not a power, this is the exponential function. So we have a base and the x appears as an exponent. So then we are going to use another rule of integral. So that will be the integral of the first function, of course, but the first function is the exponential function. I'm going to see the rule of integrations, and I notice that the integral of e to the power x is e to the power x. So this is a function in which the derivative is the same function. Of course, the antiderivative is the same function. So it will be then, as the first function will be e to the power x. So I have computed the integral of the first one. Now I'm skipping this part of writing the integral. I know that I need to compute the integral of e to the power x is this. This will be e to the power x. Then I need to compute the integral of the second function. I don't going to type the constant of integration because I know that will be several constants of integration, but I can type only one at the end. So it will be 12x squared. So it will be a constant multiplied by a function x squared. So I'm going to use the power rule, x to the power 3 divided by 3. So it will be 12, a constant, multiplied by the integral of x squared. So it will be 12 multiplied by 1/3 of x to the power 3. So we add 1 to the exponent, and this new exponent also is typed as denominator. It will be 1 over 3 x to the power 3. Or you can type x to the power 3 over 3. That is the same. And again, there is another function later, plus or minus. In this case it's minus 6x. So it will be a constant, -6. I'm going to type -6. And the integral of x, so x to the power 1. Yeah? I need to add 1 to the exponent. So the new exponent will be 2. And I'm going to type 2 also as a denominator. So it will be -6 multiply 1 over 2x to the power 2. -7. See, this is 7 times 1, yeah? So you can think that it's 7 times x to the power 0. And this x to the power 0, when the exponent 0, you add 1, you get x to the power 1 divided by 1 this is x to the power 1. This is x. So minus 7x is the number here. Anytime that you have a constant, just a constant, remember the integral of a constant is the constant multiplied by x. So we have minus 7x. And here we have another power, because this is x to the power negative 1. You notice that this 1 over x is the same of x to the power negative 1. But the power rule doesn't work when the exponent is x to the power negative 1. Because if you add negative 1, you add 1, you get 0. And 0 cannot be as denominator. You cannot use the power rule in this situation. So what you can do is just look for the rules for integration, and you notice that will be a rule for 1 over x dx, and this is the natural logarithm of the absolute value of x. So the integral of 1 over x is the natural logarithm of the absolute value of x. This is one of the rules of integration. Use this rule of integration to get this integral. So this will be then plus natural logarithm of the absolute value of x. And obviously, we need to add a constant of integration. I know that there are several constants of integration here, but I'm going to type only one. So it will be plus c. You have noticed that I have used several rules of integration here. I have used the power rule. I have used a constant times a function rule. I have used the exponential function rule. And I have used the 1 over x rule, that is the natural logarithm of the absolute value of x. I have also used the integration of the sum of different of functions. So now the only that I need to do is just simplify this expression. For example, here is 12 over 3 is 4. I can type e to the power x plus 4x to the power q minus 6 divided by 2. This is 3. So it will be minus 3x to the power 2 minus 7x plus the natural logarithm of the absolute value of x. This plus c. And this is the indefinite integral of this function here. I'm going to solve a third example. Let's say C, find the integral of the square root of x plus the cubic root of x. And any time that you have a root of a power of x, in this case it's x to the power 1, but any time that you have the square root of x to the power 3 or x to the power 5, you can type this in a power form. For example, this square root of x is the same of x to the power 1/2. So if you are going to solve this integral, there will be the integral of x to the power 1/2 plus x to the power 1 over 3. So this integral is the same of this, and in this way it's easier to understand it because now you see a power. So if this was cubic root of x to the power 2, for example, then it will be x to the power 2 over 3. So remember, the exponent is the numerator in the exponent. The index of the root will be the denominator of the exponent. Okay, so you can type this in this way and then get this sum rule of integration. So the integral of the first plus the integral of the second. And the integral of the first, x to the power 1/2, remember add 1 to the exponent, and the new exponent will be the denominator. So it will be 1/2 plus 1, the exponent, 1/2 plus 1, and also 1/2 plus 1 will be the denominator. So 1 over 1/2 plus 1 multiplied by x to the power 1/2 plus 1. And the same happens with the second one. It will be 1 over 3 plus 1, so I need to add 1 to the exponent, and the new exponent will be also at the denominator will be 1/3 plus 1. So it will be 1 over 1/3 plus 1 multiplied by x to the power 1/3 plus 1. plus a constant of integration that we know that will always appear when we are computing the indefinite integral. And then simplify this expression. For example, 1/2 plus 1, add this sum, these two fractions, 1/2 plus 1, and you know that this is 3 over 2, 3/2. So you can type 1 over 3/2, and the power will be x to the power 3 over 2. So let's see, so it will be 1 over 3 over 2 plus x to the power 3 over 2. And in the second term will be the same. 1/3 plus 1. This is 3 over 3 plus 1 over 3. It will be 4 over 3. 1/3 plus 3/3. It will be 4/3. So it will be 4 over 3 as the denominator here and also as the exponent. Plus the constant of integration. You can simplify a little more. This is the reciprocal of 3 over 2. The reciprocal of a number, because it's 1 over a number, is the reciprocal. And the reciprocal of 3 over 2 is 2 over 3. Or you can divide it to fractions. You know what to do to divide two fractions. 1 divided by 3 over 2 will be 2 over 3. So it will be 2 over 3 multiplying x to the power 3/2. Plus 3 over 4, it will be the reciprocal of 4 over 3. Or you can make the division of these two fractions. 1 divided by 4 over 3 is 3 over 4. So it will be 3 over 4 x to the power 4 over 3 plus c. And this is the result of this integral. Obviously, if they ask you using roots, you should answer using roots. And this is x to the power 3 over 2. This is the denominator is 2. This is a square root of x to the power 3. So it will be here 2 over 3, the square root of x to the power 3. The numerator in the exponent will be the exponent of the expression. And the denominator will be the index of the root. And obviously, if this is 2, the index is 2 here, the square root. Nobody write this square root, nobody write the 2. So we type it in this way. But in the second one, that I noted that x to the power 4 cubic root, because you need to type this 3 as the index of the root. So it will be 3 over 4 cubic root, the denominator of the fraction of the exponent will be the index, and the numerator of the power will be the exponent in the root. So it will be the cubic root of x to the power 4. And the constant of integration. So this is another way to give the answer. Another thing that you should notice that square root of x to the power 3 is the same of square root of x to the power 2 multiplied by x. Why thinking in this way? Because in this way you notice that this square x squared have square root. The square root of x squared is x. So you can type that this is x multiplied by the square root of x. So the x that appears inside the root is only this one. So for that reason, people, an expression like this, type it 2/3 of x root of x. You can do the same here. You see that here we have that x to the power 4. This 4 is bigger than this 3. So you can type this x to the power 4 will be x to the power 3 multiplied by x. So this expression can be written in this way, x to the power 3 multiplied by x. And this x to the power 3 have cubic root. So you can, the cubic root of x to the power 3 is x. So you can type an x outside, and the only x that is inside the root will be this. So it will be x cubic root of x. So you can write the answer as 3/4 of x cubic root of x plus c. And that is the most simplified form of this integral. Okay, with this I finish my explanation of how to compute the indefinite integral when we just need to use the basic rules of integration. I hope you have found this video useful, and if you found it useful, you should like and subscribe to the channel. Thank you.